Hello students, in this lecture we are going to discuss about control system. So let's see what we are going to cover in this lecture. We'll start with the definition and examples of control system. Then we'll discuss about the different elements that we are having in control system. After that we'll discuss about the classification of control system. Then we'll end this lecture by discussing the difference between open loop and closed loop system. So let's start. Now before defining a control system, let's define what is control. If we are having machine, mechanism or any other kind of equipment, then in that we will be having some quantity of interest, and that quantity we want to maintain or alter in a desired manner. So that process of altering or maintaining a given quantity is called as a control. So let's take an example of control. We know that in air conditioning we can maintain temperature at a desired level, or we can alter the temperature based on our need. Similarly, we are having wall fan, so speed we can control. So we can either maintain the speed at desired level, or we can again alter or change the speed based on our need. So these are the example of control. Now let's define the control system. Control system is a amalgamation or combination of different physical element linked in such a manner so that they can be regulated, directed or commanded by itself in order to obtain certain objective. This is the definition of control system. It is what? It is a combination of different physical element, and they will be linked in such a manner so that they can regulate, direct or command itself in order to achieve certain objective. So this air conditioner is also a control system because it consists of number of element that we are having in a cooling cycle, and those elements are linked in such a way that they are achieving some objective, and that objective is to maintain the temperature in a room. Next example we can have is again of refrigerator. So in refrigerator also we will be having different physical elements, and they are connected in such a way that they are achieving some objective, and that objective is to maintain the temperature inside the refrigerator. Another example of control system is this oven, where we can maintain temperature or we can change the temperature based on our need. It also consists of different elements that are achieving the objective of heating the food. This humanoid robot is another example of a complex control system because it consists of number of actuators, sensors, and they have to coordinate in order to achieve a particular task. So they will be programmed in order to execute a particular task, but the coordination between different sensors and actuator will going to occur based on the control system. Another complex control system that we will be having is in autonomous driving vehicles. So again we will be having different actuators and sensors. They will be coordinated to achieve the desired objective of moving that vehicle autonomously in a given environment. And this entire process will be achieved with the help of control system. So these are few examples. There are many more examples that we can see inside our home. And if we step out of our home, we will be able to see more number of control systems that are around us. Next is elements of control system. So first element is a system. So we can define system as combination of different physical components that are connected together to form a single unit, and that unit will be having aim to achieve certain objectives. We can take example of car. Car will be having different elements like it will be having wheel, chassis, suspension system, engine and other part, and they together form a single unit, that is car. So car is defined as a system here. Now car is having an objective of moving passenger from one place to another place. Similarly, we can take example of fan. The fan consists of blade, motor, capacitor and other part. So together they form a single unit, and their objective is to provide air. Next is plant. So plant is a portion of a system which is to be controlled. In case of car, if our aim is to achieve a speed, so our plant will be engine, because we want to control the engine how it behaves. Accordingly we will be achieving the speed, the required speed. So here in case of car, engine will be our plant, and similarly in case of fan we will be having motor as our plant, because how the motor is going to behave, so based on that we will be able to achieve the required speed. Next part is the controller. So controller, it may be a element of the system or it may be some external element that is used to control the plant. So here if we talk about the first example, that is car, so how much speed will be attained by engine will depend upon the amount of fuel that goes inside the engine, and it will be depend upon the force that we are going to provide on the accelerator pedal. So here we can consider accelerator pedal as our controller. Similarly, in case of fan, our controller will be a regulator, because that regulator is going to control the speed of fan. So here the regulator will be our controller. Next we are having input. So input is the applied signal to control a system to get the specified output. So in case of first example, that is car, our input will be force that we are going to apply. So here input will be force, and in a second case, that is in fan, how much amount of current is going to flow through that fan will be the input. Next we are having output. So it is the actual response that is obtained from control system based on how much input we are going to apply. So in case of first, that is car, the output will be the speed of car that we are able to achieve based on the amount of force that we are applying. And in case of fan, again it will be the speed based on the current that we are applying. Next is feedback element. So it is the element of system which senses the output and provide that information to the controller. So if we talk about car, we will be having a speedometer that will going to act as a sensor. So on the speedometer we can see the speed by which the car is moving. So in case of fan, if it is a normal fan, it won't be having any sensor, any feedback element. But if it is an automatic fan, then we will be having some sensor which will going to sense the speed, and accordingly based on our requirement we're going to adjust the speed. Next element of control system we can have is disturbance. So disturbance is a signal that have some adverse effect on the value of output of the system. Disturbance could be anything that will going to affect the output or that will going to deviate the output from the desired one. So in case of car, we can have like a road condition as our disturbance. If a road is not uniform, it is uneven, that will going to deviate the output of the car. So road condition we can consider as the disturbance to the system. Similarly, if we talk about the fan, so if we are having some unbalance in fan blade, so that will going to act as disturbance. Now all these elements we can connect in their logical sequence to get a block diagram that will going to represent how the signal is going to flow through this control system. So we can see here we are having a input, a reference input, and now here we are having a controller, then we are having plant here, and here we are having a control output, and also we are having a feedback element. So this is the way by which we can represent any control system. So all elements we can place in this sequence. So here inside controller, if we see here, we are having an error detector that is also called as a summing point. So it is an element of controller that will going to compare the reference input or the input and the feedback value that we are going to receive from the feedback sensor. If there is any error, then that error will be sent to the control element, and that control element will going to control the plant, and accordingly our output will be changed or modified. Okay, and this process is going to occur till we are going to get the desired output. Okay, till we are going to get the desired output. So here feedback element, it senses the output. Okay, it senses the output and send that value to this error detector where it compares input and the value that is received from the feedback element. Now let's understand that block diagram with example. We all love to drive car. If not, at least we want to sit in the car and travel around. Suppose we are having a situation like we have to attain some speed. Say that speed is 80 kilometer per hour, maybe due to some restriction or limitation on the road speed. So how we are going to achieve this speed? So in order to achieve this 80 kilometer per hour speed, what we need to do, we need to apply force on the acceleration pedal that we will be having inside car. So the force that we are applying will become an input to this system. So system here is car. So the force that we are applying on the accelerator pedal will become input to this system. Now this force through accelerator pedal will go to linkages, and from linkages it will going to actuate the carburetor. When carburetor will going to be actuated, it will going to control the flow of fuel inside the engine. So here accelerator pedal, linkages and carburetor together, they are going to form a controller. Now here this fuel will go inside the engine, and accordingly we will be having generation of power in the engine, and that will going to drive the wheel. So it will going to give us the output in the form of speed. So here engine of the car will become plant, and the speed that we are getting will become the output. Now whether we have achieved the required speed or not, so how we come to know that? It is based on the sensor that we are having on the screen in the form of speedometer. But suppose it is not there, then so in the absence of speedometer, we are not able to know how much is the current speed of the car. So in that case, by judgment, we will assume that we have achieved this 80 kilometer per hour speed. If we are not having any sensor that is monitoring the speed, so this kind of system is called as open loop control system. Now if we are having a speedometer, so what speedometer will do, it will going to monitor the speed of the car, and we will be able to see it with our eye. Now our brain will going to tell us whether we have to put more force on the accelerator pedal or we have to reduce the force based on the reading that is shown on the speedometer. So if it is above 80, we know that we have to reduce the force on the accelerator pedal, okay, that we are doing with our leg muscle. If it is less than 80, then we have to exert more force to the accelerator pedal with the help of our leg. So in this way, when we are having a control system with a feedback element or a sensor, then that is called as a closed loop control system. Okay, so both the diagram are same. One is for open loop and second one is for closed loop system. So here input is the desired speed, then driver's eye and brain is acting as a summing point or error detector, which will going to compare the desired speed, that is 80 kilometer per hour, and the speed that we are able to see on the speedometer. So it will going to compare, and based on the difference, the leg will going to apply more force or less force according to the requirement to the accelerator pedal. And based on this one, we will be having rate of fuel flow to the engine, which is a plant here, and it will going to give us the required speed that we can again monitor with the help of speedometer. So here this driver eye and brain block and leg muscle and accelerator pedal linkages and carburetor will going to form the controller block. So they together will going to form the controller block. Okay, so this will be controller block. So in this way, based on the type of system that we are having, we can represent that in the form of block diagram. Next, we'll look at the classification of control system. So first one is natural control system. So the system that we are having inside us, due to which we can walk on the two legs without any unbalance, and also different element that we are having inside, they are all natural control system. Similarly, if we talk about any biological system that we are having around us, it will be again having a natural control system. So it is the system that is created by nature. So those systems are called as natural control system. Next, we are having man-made control system. So these are the control system that are designed and developed by human being. Like we discussed about the car. So car is developed by human being. Similarly, fan also. So it is developed by human being. Then it will going to come under man-made control system. Next, we are having combination control system. So it is a combination of natural plus man-made control system. So if we take an example of car and it is driven by a driver, so we are having both natural, that is a driver, and car, that is a man-made. So together they are going to form a combination control system. So if we are having any system that will be having a natural control as well as man-made control, then that is example of combination control system. Now another way we can classify it as time varying and time invariant system. If parameters of a control system vary with time, then that is called as a time varying system or time varying control system. So here we can take example of space vehicle. What happened with time, the fuel inside space vehicle will be consumed, and because of which its weight is going to decrease with time. So here one of the parameter of your system is changing with respect to time. So if we are having any parameter of the system, of the control system, that changes with time, it is called as a time varying system. Next is, if parameters of the control system are not varying with time, then that is called as a time invariant system. So if we are having any system whose parameters are not changing with respect to time, then that is called as time invariant system. So here we can take example of fan, because the element in fan that we are having, they are not going to change, or the parameter of the fan that we are having is not going to change with respect to time. So we can consider fan as a time invariant system. Then we are having linear and non-linear system. So if the response of a control system vary linearly with respect to the input, so if we plot a graph of input versus output, if it is linear, then that system is called as a linear system. Similarly, if we are having a control system whose response does not vary linearly with input, like if we plot input versus output and it behaves non-linearly, so that kind of a system is called as a non-linear system. Next, we are having continuous time and discrete time control system. So in a control system, if all variables are function of time, then that type of system is called as continuous time control system. That means at any time you will be getting a particular value for the variables of the control system. Next is a discrete time control. So if one or more system variable of a control system are known at discrete time, then that is called as a discrete control system. So in a control system, if we are having any one digital device, then that system will become a discrete time control system. Example here, we can take a microprocessor. If we are having a control system with microprocessor, then that is called as a discrete time control system. And for a continuous time control system, we can take example of speed control of DC motor. So here, if we are using analog sensor, so this setup will become a continuous time control system. Next, we are having a single input, single output, and multi input and multi output control system. So if we talk about the first case, so whenever we are having one input and one output, then that type of control system is called as single input and single output system. So we can take example of fan here. input is current and output is speed. So we are having one input and one output. So it is a single input, single output control system. And similarly, if we are having multiple input and multiple output for a given control system, then that is called as a multi-input and multiple output control system. So example for this case we can have is like temperature control and humidity control of a room. So here input will be a power as well as a sprinkler, and output will be to measure the temperature and humidity of the room. So here we are having two input and two output, so that can be considered as a multi-input and multi-output control system. And last one is open loop and closed loop system. We can define open loop system as a system in which control action does not depends upon the output. So here we are not having any sensing element that is going to monitor the output, and accordingly we will be having change in the input. So that is not going to happen here. So that kind of a system is called as a open loop control system. So example we have already discussed is fan. Similarly, we can define closed loop control system. So it is a system in which control action depends upon the output. So here output will be continuously monitored with the help of feedback element or a sensing element, and if there is a deviation in the output, it will be rectified by changing the input that is going to flow through the plant. For example, we can take as air conditioner where we set the temperature. So if the temperature reaches to the desired level, your system shut downs. But if there is a change in temperature, maybe it goes above, so accordingly it will going to switch on and will again trying to maintain the same temperature in the room. Now let's discuss about the difference between open loop and closed loop system. This is one of the most used classification of control system. So let's see the difference. For open loop system, control action does not depends upon the output. Okay, why? Because we are not having any feedback element, so it is not going to monitor the output. Similarly, for closed system we will be having control action depends upon the output. So here we are having feedback element that is going to monitor the output, and if there is a change in the output, it will be adjusted based on the feedback signal. Now when we talk about the open loop system, they are simple in construction and design also, but when we talk about the closed loop system, they are complicated in design because they involve more number of components. Now because of the simplicity, open loop system are economical, and because of the complexity, closed loop system are costlier. Now since open loop system are not having more elements and they are also not complex, so they are easy to maintain. So when we talk about the closed loop system, their maintenance is difficult. Open loop system are used when output is difficult to measure. So this is we can consider as one of the biggest advantage of open loop system. If we are not able to measure the output, so in that case we will be designing a open loop system. But we cannot have a closed loop system where it is difficult to measure the output. As in open loop system, feedback element is not present, so they are not accurate and reliable. And when we talk about the closed loop system, as they are having feedback element that we're going to continuously monitor, so they are accurate and reliable system. Now here in open loop system we can have a number of example like electric hand dryer, electric lift, and similarly traffic signal, because they are also having a fixed response and they are not having any feedback element. So these are the example of open loop system. And for closed loop system we are again having number of example like automatic electric iron. So as the temperature is achieved, it switched off, and again temperature falls below certain level, so again switch on and start heating. And there are air conditioner, which is also an example of closed loop system. So these are some differences between open loop system and closed loop control system. Before ending, let's revise what we have covered in this lecture. We started with the definition and examples of control system. After that, we have discussed about the elements of control system. Then we have discussed about the classification of control system. And after that, we discuss about the difference between open loop and closed loop system. So with this, we'll end this lecture.